Hi. So today we're going to talk about the relationship between pressure and volume of gases, also known as Boyle's law. You should be able to use the pressure-volume relationship to determine either the final pressure or volume of a gas if the temperature and the amount of gas are held constant. This one's interesting to me because it kind of makes you think about your body in ways that maybe you haven't before. For instance, what happens to us in space without a spacesuit? Why do we wear spacesuits? Other than the huge amounts of radiation, freezing temperatures, and lack of oxygen, our bodies have evolved on Earth to have our outward pressure balances the pressure, the air pressure. So inside your body, it's pushing out your blood and other fluids to keep you from collapsing as air pressure pushes in on you. So if you were in space without a suit, you wouldn't have this outward pressure. So if you have had physical science or physics, you know that acceleration happens when you have unbalanced forces. So you would just expand outwards. You have a giant head like my son when he was a baby. Anyway, I put a link there for you to click. Lots of other horrifying things happen to you, but it's just interesting to me to think that our bodies would just kind of blow up. So Boyle's law states that the pressure of a gas is inversely related to the volume when the temperature and the amount of moles are held constant. So that means as one increases, the other decreases. Here you just have a canister with a piston. If you notice the first one, 4 liters, 1 atmosphere. If you decrease that volume to 2 liters, notice that the pressure doubles. So as one decreases, the other increases. That should make sense. If you think about squishing these molecules, if your pressure comes from them hitting the container, they're going to hit the container more because the area is smaller. This is how an inverse graph looks. You should know this for sure because it comes up a lot on standardized tests and also just with science in general. But I can't talk. So here is Boyle's law. P1V1 equals P2V2 when temperature and amount of gas are constant. So that's your pressure 1, volume 1, pressure 2, volume 2. Your pressure can be in atmospheres, kilopascals, torr. Volume's generally going to be in liters or milliliters. If you notice, as your pressure is decreasing, as it's going down here, your volume is getting larger. So that's an inverse graph. You can solve it for any of these variables. Starts out P1V1 equals P2V2. So to find any of these, you're just going to divide. If you were looking for V2, you would divide both sides by P2 to cancel it out. This is just basic algebra. I highly recommend solving your formula for the variable that you're missing before you start putting numbers in the thing. But that's just me. Here's how we use our gas laws. Organize your data into initial and final conditions. Gotta get really good at reading word problems. Rearrange your gas law equation to solve for the unknown quantity. Also here, if you're trying to do lazy math, when your unknown quantity, if you know that you're looking for a pressure, then you know that your units should be either atmospheres, torr, millimeters, mercury. Before you even start, you know what units that you should end with. And then you're going to substitute your values into the gas law. Example 1. Freon 12, CCl2F2 is a gas used in refrigeration systems. What is the new volume in liters? So that's my unknown. Of an 8-liter sample of freon gas after initially at 550 millimeters of mercury. So that's going to be my P1. After pressure is changed to 2200, so that's going to be P2, add a constant T, and then it gives us that it's 8 liters. So that has to be volume because it's liters. So now these are my givens, V1, P1, and P2. I'm looking for V2. So I'm going to solve my gas law for V2, which means I'm going to divide by P2 to get V2 on a side by itself. So V2 equals P1 V1 over P2. And now I can just plug in. P1, 550. V1, 8. And P2. So 550 times 8 divided by 2200 is 2 liters. Well, let's see if that makes sense. So if my pressure went up, that means my volume should have went down, and it did, so yay. I always list out my variables and fill in my unknowns and givens, and then solve the equation and plug in. This is the Pearson one where they did it in tables. It's the same thing. It just seemed like too many words to me. There you go. Units are canceling, putting us in liters, but if you know what you're looking for, you knew it should have been liters to begin with, so you didn't have to do that part. This question is more conceptual, so like if you're looking at cylinders of gas, indicate if A or B represents a new volume for the following changes. N again is moles of gas, that's how much gas is in there. T is temperature, and Kelvin, if we're lucky. So if here was your initial one, and you wanted the pressure to decrease, so if you wanted the pressure to go down, that means that you would need a larger volume. If you wanted your pressure to increase, you want to squish it, compress it, and that would be 8. So just think inverse relationship. So one goes up, the other goes down. There's your answers. Here's another one. If you had a volume of 6.4 liters at a pressure of 0.7 atmospheres, at 1.4 atmospheres, is the new volume represented by A, B, or C? Volume 1, pressure 1, sorry, pressure 2. So since my pressure went up, that means that my volume had to go down. Another cool thing about pressures is the way your lungs work. Wow, that's super loud. So as you breathe, your pressure in your lungs increases and decreases. What happens is when you inhale, your lungs get bigger. The pressure decreases, so the air is like pushed into your body because you've got a lower pressure here, higher pressure here, so the gas molecules actually are pushed in. When you breathe out, your lungs get smaller, diaphragm pushes it up, the pressure here is higher than outside, so the air flows back out. I just thought that was like a cool biology thing for you guys. Okay, well, hope this helps. Bye.